By the end of this year, the phone in your pocket might be illegal to export, not because of a software ban, but because of the dirt inside it. There is a silent war being waged inside the pocket of your jeans. Every time you unlock your phone, start your Tesla, or track a location via GPS, you are unknowingly relying on a handful of elements that most people can't even name. These are rare earths, the vitamins of the 21st century, and the invisible nervous system of modern civilization. Without them, the high-tech world we've built would simply grind to a halt. For the last 40 years, the West didn't just overlook this dependency. They handed the master key to this vital technology to a single gatekeeper. Now, in 2026, that gatekeeper is turning the lock. With China controlling 90% of the world's refined supply, they have officially weaponized the very ground we stand on. This isn't just a trade dispute, it's a global race for sovereign survival. As the supply lines tighten, the question is no longer if the world will change, but who will be left holding the power. So if you want to stay ahead of this global shift and never miss a deep dive into the forces shaping our future, make sure to hit that subscribe button and turn on all notifications right now. Number 1. The hidden foundation of modern life. Rare earths are used in tiny amounts, yet their importance is absolute. A fighter jet, a satellite network, a wind turbine, or an AI data center may rely on only grams of these materials. But without them, the entire system fails. These elements give modern technology its edge, enabling efficiency, durability, and miniaturization that conventional materials cannot achieve. Their magnetic and optical properties allow motors to deliver more power with less energy, sensors to track motion and position with extraordinary accuracy, and electronics to remain stable under heat, vibration, and electromagnetic stress. This is why rare earths appear across sectors that define modern power: aerospace navigation, missile guidance, renewable energy grids, high-performance computing, and advanced medical equipment. Unlike steel or copper, rare earths are not interchangeable. Removing them often means redesigning entire systems from the ground up. They are the key building blocks of modern tech. Control over these materials doesn't just influence manufacturing. It determines who can innovate, defend, and lead in the technologies shaping our world. Number 2. The 1980s handover. This crisis was not an accident. It came from decades of strategic neglect. In the mid-20th century, the United States dominated the rare earth industry through facilities like the Mountain Pass mine in California, supplying both civilian and defense needs. But as environmental awareness grew in the 1980s, rare earth processing collided with stricter regulations and rising public opposition. The industry was increasingly seen as polluting, complex, and politically inconvenient. Instead of modernizing at home, Western economies shifted focus towards software, finance, and service-based growth. China chose a different path. It accepted the environmental and industrial burden in exchange for long-term strategic control, investing heavily in chemical engineering expertise, infrastructure, and scale. Over decades, it mastered the hardest part of the supply chain: separation and refining. By the early 2000s, global manufacturers had little choice but to rely on Chinese processing, not because alternatives didn't exist, but because they had been systematically abandoned elsewhere. Number 3. The anatomy of a smartphone. To understand what this dependency really means, consider the smartphone in your hand. Behind its sleek design lies a dense network of rare earth components that make modern performance possible. Neodymium enables compact yet powerful vibration motors and speakers, while europium and other phosphors deliver sharp color accuracy and brightness on high-resolution displays. These elements are not chosen for convenience. They are chosen because no widely available substitutes offer the same performance at scale. What makes this more significant is that most of these materials have passed through the same refining ecosystem, tying everyday consumer devices to geopolitical supply chains. This dependence is largely invisible to users, yet deeply embedded in global manufacturing. If access to these refined materials were disrupted, production wouldn't merely slow, it would stall. The smartphone becomes a clear example of how geopolitics now reaches directly into daily life, transforming ordinary consumer electronics into leverage points within a much larger strategic contest. Number 4. The refining trap. Why mining alone isn't the solution. The true crisis of 2026 is not a shortage of rare earth minerals in the ground, but a shortage of places that can turn those minerals into usable materials. Elements like cerium and lanthanum are relatively abundant, yet abundance alone means nothing without refining capacity. The most difficult and valuable stage of the supply chain lies in chemical separation, where raw ore is transformed into ultra-pure oxides and metals. This process requires specialized infrastructure, experienced engineers, and long-term waste management systems, all of which are expensive and politically sensitive. As a result, even mines operating in the United States, Australia, or Brazil often remain dependent on overseas processors. What began as a cost-saving measure has evolved into a structural vulnerability. Control over refining allows influence not just over supply, but over timing, pricing, and prioritization. Until new processing facilities are built and stabilized elsewhere, mining alone cannot break this dependency. Number 5. The 2026 Counter-Strike, launching Project Vault. Facing growing supply uncertainty, U.S. policymakers moved to reduce immediate exposure rather than solve the problem overnight. Project Vault represents a defensive strategy aimed at cushioning critical industries from sudden disruptions in rare earth access. Modeled conceptually on strategic reserves used for energy security, the initiative focuses on securing stockpiles of the most essential rare earth materials used in defense systems, electric vehicles, and advanced electronics. By combining public funding with private sector participation, the program spreads risk while ensuring that materials remain available during periods of geopolitical stress. This approach is not intended to replace global supply chains, but to stabilize them during emergencies. Stockpiling buys time for manufacturers and governments to adapt, invest, and diversify sourcing. However, it is ultimately a stopgap measure, one that highlights how exposed modern industry has become to a single point of failure. Number 6. The South Korea Truce, a hostage economy on pause. Geopolitical tensions reached a critical point after the 34% tariffs imposed on Chinese goods in 2025. Triggering a rapid escalation across global supply chains. Beijing's response tied export controls requiring special licenses for rare earths sent a clear signal that access to these materials could be selectively managed. By early 2026, manufacturers around the world were no longer operating under free market conditions, but under what analysts began calling a conditional supply system. Materials were available, but only as long as political circumstances allowed. Alarmed by the risk of production shutdowns across automotive, defense, and electronic sectors, diplomats moved quickly to stabilize the situation. High-level negotiations in South Korea resulted in a temporary delay of the most restrictive measures, effectively pressing pause on the crisis. Yet this agreement offered no structural solution. It simply postponed the consequences, leaving industries dependent on a fragile diplomatic balance. The truce bought time, but it also confirmed that economic security had become inseparable from geopolitics. Number 7. Urban mining and the space metal miracle. As traditional diplomacy offers only short-term relief, attention has shifted toward technological escape routes from rare earth dependence. One of the most closely watched developments is the industrial synthesis of tetratenite, an iron-nickel alloy once found almost exclusively in meteorites. Its magnetic properties closely resemble those of rare earth-based magnets, making it a potential game-changer if produced efficiently at scale. While still experimental, progress in this area reflects a broader push to redesign materials rather than merely secure them. At the same time, companies are looking inward toward the vast reserves already embedded in existing products. Discarded smartphones, electric motors, and electronics contain higher concentrations of rare earths than many natural ores. Apple's $500 million partnership with MP Materials represents a serious move toward urban mining, aiming to recover rare earths from old devices with minimal waste. Together, synthetic alternatives and advanced recycling signal a shift from extraction to innovation, redefining where future resource power may come from. The mineral crisis of 2026 has proven that geography is once again destiny. For decades, the global economy operated on the illusion that supply chains were borderless and that politics were secondary to profit. Today, that illusion is shattered. The one-year truce negotiated in South Korea may have provided a temporary reprieve for automotive and defense giants, but it has not changed the underlying math. As long as one nation holds the refining master key, the rest of the world is operating on borrowed time. The race to 2027 is no longer about who can build the fastest phone or the sleekest car. It is about who can guarantee the molecules required to build them at all. We are witnessing a fundamental re-architecting of global power. From the $12 billion Project Vault to the desperate search for space metals like tetrataionite, the West is finally playing the long game to reclaim its industrial sovereignty. However, infrastructure cannot be conjured overnight, and the gap between dependency and independence remains a dangerous minefield of price volatility and diplomatic tension. The next few years will determine if we successfully transition to a diversified circular economy powered by urban mining and synthetic alternatives, or if the high-tech civilization of the 21st century remains a hostage to the ground it was built upon. The lock has been turned. How we choose to answer will define the next century of global leadership.